Hello, I'm Channa Bankapur. I'm going to discuss my solution to the LeetCode problem, mirror reflection. It's today's daily challenge in LeetCode. The problem definition is we have a square room with mirrors on all the four sides, and length of a side is p, which is given here, and all of them has mirrors in all the corners, and but three corners labeled as 0, 1, and 2 have some kind of receptors. Receptor means it's going to figure out when it receives a laser, right? um, and one of the corner is southwest corner, which let's label it as 3. So we are going to initiate a laser ray from southwest corner, and it's going to first intercept the wall between 0 and 1 corners at a distance of q from 0, and that is going to define what is the direction this light is going on. So because it's a laser light, the direction is going to be very clear, and also the reflection of mirrors is going to define how it is going on. So it is guaranteed that at least the problem guarantees that uh, it is going to intercept one of these corners, 0, 1, or 2 at some point. So we need to find out uh, the first of these corners which is going to be intercepted by this light. They say that it is not going to intercept corner 3 again. It is going to be one of these three. So we need to figure out which one is that. So to understand these kind of problems, because it's a mirror and reflection is perfect here. So instead of looking at the reflection, we can think of this is like an infinite, a building with lot of rooms, like square rooms like this, where there is no wall here. It is more like, just receptors at these corners, and light just, goes like this. So that way, this is going to go unmade. So if think of this as an adjacent room, we can have the corners mapped in the similar way. So this is more like a reflection of that room. So that's why these corners are 0, 2, and 3. And so in this case, in the example, p is 2 and then q is 1. So q is off of p. So that's why when the light travels 2 units of p in x-axis, it travels 1 unit of p in y-axis, right? That is the ratio of p is to q. So that's why it's going to meet corner 2 when it travels 2 p's in x-axis. But yeah, we don't have to stop here. What if q is like one third of p? So in that case, in one p units in x-axis, in y-axis we are going to travel one third of q. Sorry, one third of p, because q is one third of p. And in the second cycle, we are going to travel two third of p. And in the third cycle, we are going to travel one more, and then we are going to hit this corner, which happens to be corner numbered 1, right? So that's so at least we can figure out if q divides p. Things are very easy. Depending on the quotient, whether it is even or odd, it's going to hit either corner number 2 or 1, right? To reduce the analysis, I'm gonna modify this p and q to some extent. Say suppose p and q could be in terms of centimeters, some unit, right? Some unit of length. P and q could be in centimeters. But what if both of them are even? Like, what if p is 6 and q is 2? In this case, if I reduce this into p as, so this is 6 centimeters and this is 2 centimeter, right? So instead of that, what if I reduce this into 3 units and 1 unit? 1 unit here is essentially 2 centimeter. So we are dealing with the same length, just that the unit of length is different, right? That should be okay. That's why if you have both of them as even, we can easily just divide both of them by 2 and then reduce it. Yeah, but if one of them is even and the other one is not even, do not divide, because it's going to get into fractions, right? We don't want to deal with any fractions right now. We want to deal with only integers. So I'm going to reduce p and q in such a way that both of them are not even. So the possible cases are uh, either p is even, or q is even, or both of them are odd. So these are the only three possibilities we are left out with, right? We are not going to have both of them being even. Now let's look at this, what happens in this scenario. So maybe I'll go further and then show you what happens here. So this is going to be corner number 2 and this is corner number 3 again. So if q is even lesser than that, like maybe 1/4 of it, 1/4 of p, then it's gonna go and hit this corner, which is 2. If it is 1/5, it is going to go and hit this corner again, which is 1 here, right? So that thing is clear. So if Q divides P, it is good. But what if Q does not divide P, right? So in that case, what happens is it's not going to end here in the first iteration. So it's going to go further up. So it'll, suppose if Q is 2/3 of P, right? It's going to come here and then it'll go up here. When it goes up, you can now think of this as an infinite space of two-dimensional space. You don't have to think of these as mirrors now. So the light is going to just travel this way, right? Or actually, instead of going that way, I'm going to go in this direction itself. So this is how we can think of. So this is 2/3 of P already after first unit of P in x-axis. In the second unit, it's going to go to somewhere here, which is 1/3 of P after 1 unit of P, right? More like 4p/3 length, which is not a corner, but in another unit, it's going to touch this corner. So what is this corner? If you again label them, I'm going to label them as 0, so 3, 0, 3, 0 here. So this is corner 0. So we are hitting corner 0 here. So what does it indicate here is, here Q is not dividing P, but Q divides 2P. So when Q divides 2P, we have a reason to hit 0. It turns out that when Q divides 2P, it has to hit a corner in this level where there are the only available corners are 3 and 0. And we know that from the problem already guarantees that we are not going to hit corner number 3. So we have to hit corner number 0. So if Q divides 2P, not just 2P, if it is even 4P or 6P, right? All of these things, if Q divides, then it's gonna hit corner number 3. What does that tell us? We know that both of them are not even, but if Q divides 2P or 4P or something like that, Q has to be even. P is not even in that case. So P is odd and Q is even. So if P is odd and Q is even, which is here, in this case, the corner we are going to hit is 1. Sorry, 0. Sorry, this is the corner number 0, which is labeled, which is next to, which is essentially southeast corner, right? So that part is clear. Now, what if it goes further up? So in this next level here, these are again the corners which are labeled as 2, 1, 2, 1 likewise, right? So again, in this case, Q should divide 3P. So earlier here, Q divides P here in the first level, but in the third level, Q divides 3P. And then you can think of another level where Q divides 5P and so on. So whenever Q divides 1P or 5P or 3P or any number of odd number of P, we are going to hit one of these two corners, right? 1 or 2. So now again, you know that both P and Q are even is not allowed. So Q cannot be even in this case, because if Q is even, we know that this is the case we're going to get. If Q is not even, P can be even or odd. Actually, both of them are possible now. So depending on whether P is even or odd, there are two possibilities. If you observed already here, if P is even, so then we are going to hit these columns, which is corner number 2, what we see there. So we already saw that in the first few examples. If P is even, whether it is 2P or 4P or 6P, we are going to hit corner number 2. So that's what happens if P is even and Q is odd, we are going to hit corner number 2. So that is this case. When P is even and Q is odd, we are going to hit corner number 2. Otherwise, if both of them are odd, so we have this case where the corner number 1 is going to be hit. So that's what we have, right? So because of the input limitations here, I'm not getting into the details of exactly what happens, what are the possibilities, what if the light travels forever, what if it's going to hit corner number 3, right? So those things are not discussed here. So these three cases are easy to figure out, and that's all we need to know, right? So that's how I'm going to use this idea of these reducing it into these three possibilities and looking at uh, uh, whether P is even or P is odd or Q is odd. So just looking at the parity of P and Q, I can decide which corner it's going to hit, given that it's going to hit one of these three corners, 0, 1, or 2, right? So that's how the code is going to be extremely simple for me. Let me show you my code. So I have reduced P and Q. As long as both P and Q are even, So I keep reducing it. So if you see here, if whenever both P and Q are even, I keep dividing them by 2. So dividing by 2 is as good as right shifting by 1. So I just keep doing it. So when I come out of that, so now we know that, but at line number 11, we know for sure both P and Q being even is not allowed, right? At least one of them is odd. But if P is even, so we already figured out it's going to hit corner number 2. And if that is the case, then P is definitely odd. So either Q is even or Q is odd. If Q is odd, we know already figured out this is the case of both being odd, right? Both are odd. So in this case, we figured out it's going to hit corner number 1, right? So the only left out case is when P is odd and Q is even. So in that case, we know that we cannot hit corner number 3. So there is only one column which is corner number 0, right? It's going to be hit, right? So that's how simple it is. And this solution works. Let me submit and show you. So it is accepting. And if you want to know what is the time complexity here, it's actually really fast because all I'm trying to do here is, so this is the only thing which takes some time. And this is handling at a bit level because we are kind of right shifting P and Q by 1. So it's actually, it's not more than log of P or Q or P plus Q. Or actually we can think of, suppose if you write P and Q in binary, it's basically the number of rightmost zeros, which is which is min of rightmost zeros of both of them. Suppose if you have P and Q like this is P, this is Q, we only get rid of these two zeros there, and then we're going to stop. And that's how much while loop runs. And after that, we only look at the one next bit here. We don't even worry about anything else after that. So in the worst case, we can say that this is log of P, max of P at Q, but it is actually even much faster than that on an average case. All right, so that's how this is probably the most efficient solution. All right, so if you have any other way of explaining that, obviously there are different ways of explaining this using optics theory and lattice theory, and physics is going to help you and geometry is going to help you. So there are multiple ways. So if you know any other ways, please let me know in the comments below. But if you like the solution, please like the video and subscribe to the channel. Um, keep solving a problem every day, and thanks for watching.